Hi guys, let's talk about how to use the empirical rule. So you should have read my notes already on the empirical rule. And it kind of talks about different percentages and stuff like that. I'm going to show you how you can actually use those and a little bit more support on why these percentages work. So the first thing we need is we need a normal distribution. Now what this means is you need something that has one hump and it's roughly symmetric, okay? So these curves here, each of these is a normal distribution or approximately normal distribution. So kind of all the data is centered towards the middle, one big hump, and it's roughly symmetric on both sides. So what the empirical rule states is that if you have a normal distribution, if you look just one standard deviation above and one standard deviation below the mean, if you're within one standard deviation above or below the mean, that's where 68% of the data is going to fall. If you look between two standard deviations above and two standard deviations below, you're going to have 95% of your data. And then if you go three standard deviations above or three standard deviations below, that's 99.7% of your data will be within three standard deviations above to three standard deviations below. So when we talk about the empirical rule, some people call it the 68, 95, 99.7 rule, which follows those three numbers. Now, what's important to us is when you use the empirical rule, it's nice to draw a normal distribution, label your mean, and then count 1, 2, 3 standard deviations above and 1, 2, 3 standard deviations below. Now, what we're going to do is I'm hoping to label what percentage of data is just in, say, this gap right here. So from the mean to one standard deviation above. I want to know how much percent of my data falls in there. I can also do that, figure out how much percent of my data is between one standard deviations above and two standard deviations above. So you kind of see all these dashed lines here. I want to know what percentage of my data is inside of every single one of those intervals. Now, how we're going to do that is we're going to use the idea of symmetry, and we're also going to use what percentages we do know. So if we just start off with these first two kind of sections, so this is from one standard deviation above to one standard deviation below. Altogether, that should be 68% of our data, but if I split that in half, because remember this is symmetric, 68 divided by 2 is going to give you 34%, which of course my pen doesn't work. There we go. 34% falls in this first section here and this section here. So 34% of your data is between one standard deviation below and your mean, and 34% is between your mean and one standard deviation above. So we're going to kind of continue this pattern on outwards. If you look at 95%, a total of 95% of your data should cover this entire area. But we've already accounted for 68%. So if you take that 95 and subtract off 68, you're going to be left with 27% of data is unaccounted for in this section. So this right section plus this left section should add up to 27%, because then all four of these sections adds up to 95%. So if we take that 27% and divide it by 2, you're going to get 13.5% over here and 13.5% over there. We're going to kind of continue the same pattern and trend on outwards. So when I have 3 standard deviations above and 3 standard deviations below, that's 99.7% of our data. But again, I have 95% accounted for. So if you take 99.7 and you subtract off the 95, you're going to be left with 4.7% of our data is unaccounted for. But if you split it between those two symmetrical sections, 2.35 will be over here and 2.35 will be over there. Now, if you take all these numbers right now and add them all up, it will add up to 99.7%. So we're missing 0.3%. 0.3% is going to hit our most extremes, this outer part over here and this outer part over there, our most extremes. So altogether, these two sections should add up to 0.3%. So if we split it in half, 0.15% over here and 0.15% over there. Now, if you look around online, a lot of these different tables are available everywhere. I'm just explaining the math on what comes behind these numbers and how it's produced. So what I want to look at is, okay, now that we know how this empirical rule shapes out, how can we actually use this to answer some questions? So here we have the weights of 10-year-olds are normally distributed with a mean of 120 pounds and a standard deviation of 5 pounds. Use the empirical rule to answer the following. So we're going to figure out the percentage of 10-year-olds who weigh between 105 pounds and 125 pounds. And we have a few other questions. I have another piece of paper we're going to look at. The first thing I would do if you're going to use the empirical rule is just draw your normal distribution and label your means, your standard deviations, and your percentages. So what I'm talking about is we need a normal distribution here. So I'm drawing just that exact same curve that I kind of did up above. So in the center is going to be my mean. I need to go one standard deviation above, one below, two above, two below, and then three above and below. So in the center is my mean at 120 pounds. And then I know my standard deviation is 5 pounds. So it's just a counting game. So every time I move up a standard deviation, I'm going to add 5 pounds because the standard deviation is 5 pounds. So this mark would represent 125. This mark, 2 standard deviations above, would represent 130. 3 standard deviations above would be 135. So I just counted by 5s. Plus 5, plus 5, plus 5, because that's my standard deviation. I'm going to do the same thing, but I'm going to go below. So if I'm at 120, subtract 5 takes me to 115. Subtract another 5 takes me to 110. Subtract another 5, that takes me to 105. Now another thing that's useful is I'm going to go ahead and copy down those percentages we just talked about up above and label all these sections. It's going to make my life a lot easier here. So remember the inner two are 34. Then we have 13.5 and 13.5. Then we have 2.35 and 2.35. And then finally in the very ends, 0.15 and 0.15. Okay, so now I can get to my actual questions here. So a little bit of building to get here. I need to find the percentage of 10-year-olds who weigh between 105 pounds and 125 pounds. So I'm only curious about the sections from 105 to 125. So 105 starts here, 125 is all the way up here, okay? So I need all of that area in between from 105 to 125. So that means I need this 2.35, I need this 13.5, I need this 34, and I need this 34, and then we stop. So I'm going to add up all those percentages from 105 to 125. So I'm going to be taking 2.35 plus 13.5 plus 34 plus 34. And if you add all these numbers together, you're going to get your answer to this question. So when you type all these in a calculator, add them up, you're going to get 83.85%. So 83.85% of 10-year-olds will weigh between 105 and 125 pounds. So let's do another question here. Find the percentage of 10-year-olds who weigh less than 130 pounds. So pay attention here. We want less than 130 pounds. So I'm going to find 130, which is right here. And I want all of these percentages below 130 pounds. So I need the 0.15, the 2.35, the 13.5, the 34, the 34, and the 13.5. And I'm going to add them all up. So here we go. 0.15 plus 2.35 plus 13.5 plus 34 plus 34 plus 13.5. And if you add all those together in a calculator, you're going to get 97.5%. So 97.5% of 10-year-olds should be less than 130 pounds. 2 more quick questions and we'll wrap up here. So I have a question C here. Find the percentage of 10-year-olds who weigh between 110 pounds and 125 pounds. Same idea. find the percentages in between. So 110 is right here, 125 is right there. So we just need to add up all those percentages from 110 to 125. So we need a 13.5, a 34, and another 34. 13.5 plus 34 plus 34. If you add all those together, you're going to get 81.5%. Our last question here, we're going to find the percentage of 10-year-olds who weigh at least 115 pounds. So when we say at least 115 pounds, that means 115 pounds on up. So we need to go 115 on up, increase that amount. So 115 is right here. I need all these numbers to the right. So I'm going to show you how we traditionally do this, and I'm going to give you a little tip on another way you can do this. So 115 on up means take 34 plus 34 plus 13.5 plus 2.35 plus 0.15. You add all those numbers together, you should get 84%. So that's 115 on up. Now there is a trick on how you can do this. We know the entire area under the curve should add up to 100%. So they wanted, what is the probability that it's 115 pounds, at least 115 pounds? So we added 34, 34, 13, 2.3, and the 0.15. You could go the opposite way. If you take the numbers that don't qualify for this, which is these three numbers, 0.15 plus 2.35 plus 13.5, and if you take those numbers and you subtract them from 100%, guess what you're going to get? You're going to end up with 84%. So you can kind of use that to your advantage if you want. If that's a little bit too confusing, then just don't touch it. Just add up all the numbers that apply to whatever the question is asking for. So start with a normal curve, label all your means and standard deviations, and then plug in your percentages. And that was my video on using the empirical rule.